All right, we're going to take our time today just so we can all remember exactly what it is that we need to know in terms of quadrilaterals. And we're hopefully going to answer these questions in a nice, timely manner. All right, okay, here's our first question. All right, it says here, KLMN is a rhombus. So we're going to stop right there. We're going to stop right there. Everybody, tell me, pop your answers in the chat. If you want to raise your hand too, I'm happy to have you raise your hand. Remind me, what are the properties of a rhombus? Who knows? Any property that you can think of. Good. Opposite angles are equal. Excellent. Opposite angles are equal. Excellent. Diagonals bisect at 90 degrees. That's it. Anatida, beautiful. Diagonals bisect. That word bisect is very important. Who can remember, what does bisect actually mean? What does bisect actually mean? Well done, Unati. Equal sides. Good. What does the word bisect actually mean? Correct, Onako, that's it, beautiful. The word bisect is very important because it's completely different from intersect. Okay, intersect means that two lines cross each other, but bisect means that the one line cuts the other in half, in exactly half. So when they bisect, it means that as soon as they cut each other like that, if this one bisects the other, that means this side and this side are automatically equal. That's what bisect means. Okay, that's exactly what bisect means. Mfundo says the sum of two adjacent angles is equal to 180 degrees. Correct, that's on a straight line. But we're looking specifically for questions on, on a rhombus, the properties of a rhombus. Okay, the equal sides, yes, they bisect. Anything else? Anybody know anything else that we should know here? Right? What do we know about the opposite sides of a rhombus? Opposite sides of a rhombus are what? Good, they're equal, but they're also what? Not just equal. That's it. Yes, Onako, they're also parallel. Beautiful. So in this case, we will know that KN is parallel to LM and KL is parallel to NM. So we've already got so much information before we even look at our questions. And I can guarantee you that so much of this is going to answer the questions that we need. Hello, DeAndre. It's lovely to have you with us today, my sweetie. It's great to have you. All right, let's look at question 8.1.1. All right, it says here, write down the size of angle O1. Thank you, Anotida. Anotida, you're just like a whole boss for giving us the answer. Everybody pop your answer in the chat. What is the size of angle O1? I love it when people give us answers before we've even asked for them. What is the angle of O? What's the size of angle O1? Okay, think about the property that Anotida's given us. Correct, Siam Tanda, well done. That's it. It's equal to 90 degrees. All right, because Anatida's already told us that the diagonals of a rhombus bisect at 90 degrees. So this is the diagonal right here. This is the bisect, which means O1 is 90, O4 is 90, O3 is 90, and O2 is also 90. All right, so we automatically know that O1 is equal to 90 degrees. Well done. One free mark, a free mark. Yes, Kamogelo, it should. But yours is a little bit more complicated because it has a lot to do with cyclic quads, which is something completely different. Kamogelo, let me have a quick chat with you once I've given everybody else some time. All right, the next one says, calculate the size of L. Right. We can calculate for the size of L because we know that our diagonals cut our rhombus into another shape. What other shape do we see inside our rhombus? A what? Good, Tamia, that's it. We see triangles everywhere, right? And I can already tell that in triangle KOL, right, I can figure out what that angle over there is. And in triangle KLM, I can also figure out what that angle over there is. All right. We can already kind of tell. Right. So everybody, 2 marks. Find me the size of L1. Oh, I don't even need L2. I just need L1. Find me the size of L1. You can pop your answers in the chat. It's not even that deep, guys. They're going to give you 2 marks for this. Oh, by the way, remember, O1 is equal to 90 degrees. Okay. So my clue is in triangle KOL. Okay, Manila and Onako already have the answer for us, but you're not done because we are doing geometry. We're doing geometry. So you can't just give me an answer. You can't just give me an answer. What do I need? What else do I need? Not just degrees. Come on, guys. I need a statement and I need a what? Yes, Nicole, absolutely. I need reasons because I'm only going to get 1 mark if I don't tell them the reason. I must give them reasons. That's correct, Manila. We must also say the interior angles of a triangle add up to 180. We can't just say that L1 is equal to this. No, we must be very specific. All right. Luckily for us, this is grade 12. I'm saying grade 12. It's where my mind already is. Luckily for us, this is grade 10. So we can skip steps. We can go straight to saying that angle L1 is equal to 56 degrees. We can just give them the answer and give them the reasons. We can say angles, sum in triangle, however you write it, angles in a triangle, interior angles of a triangle add up to whatever, whichever way you've been taught how to write it, it's probably going to be correct. Okay, and those are your 2 marks there. There's 1 mark, there's the other mark. That one was also 1 mark. All right, now they say calculate the size of KNM. Let's look at it. KNM. They want that whole angle. Let's talk, guys. How do we get there? Who's got an idea for me? Good, Onako? Yes, we are aware that the opposite angles are equal, but that only tells us half the story. Okay, that tells us half the story. Because even though we know that L is equal to N, we know that they're equal. Yes, good, Siam Tanda and Stephen, that's exactly what it is we want to use. Yes, I'm seeing Jessica say Reuer Saande hoeke. I know what hoeke is. Hoeke is angle. Everything else, I have no idea what you just said. Nothing at all, my sweetie. The rest, me, I don't know. Okay, right. Okay, luckily for us, we know, right? We know that if L1 is equal to 56 degrees, right? That means N2 is equal to what? Good, Onako. It's also equal to 56. And that means that N1 is also equal to 56. Why can ma'am say that both of these are equal to 56 degrees? Not quite alternate angles. Yes, correct, Isayan, on the first part. We know that L1 is equal to N2, which is equal to 56 degrees, 100%, and that's alternate angles. 100%. Remember, when we use alternate angles, we must also name our parallel lines. So I'm going to go KL is parallel to NM, right? Now, why can I then come to the conclusion? I can then just say, therefore, therefore, N1 is equal to 56 degrees as well. Why can I make that statement? Why am I allowed to make that statement? Okay. If we go with what Isayan has said, that one and that one are equal to each other, 100%. Teacher Coco says this one is also equal to 56 degrees by default. Why is that? Yes, we can say it's the same angle, but that doesn't explain it 100%. That's it. Correct, Stephen, because my diagonals bisect. What did we say bisect actually means? Yes, good. Diagonals bisect. Thank you, teacher Nels. That's it. That's it. My diagonals bisect. They don't just cut, Mfundo. How do they cut? Thobela amogelang. Not 90 degrees, correct, Onako, that's it. Not only do they cut when they bisect, they cut exactly in half. So if this is 56 degrees, then N1 will also be 56 degrees because my diagonals bisect my angles as well. Therefore, I'm still not done. Angle KNM. What is the size of the full angle? What is the size of my full angle? Because they didn't ask for it in pieces. They asked for the full angle. Be careful, Jessica. We want this full angle over here, this whole one. Good. Awesome stuff, guys. My full angle is 112 degrees. Well done. Beautiful stuff, guys. Very, very nicely done. Okay. Very nicely done. All right. Give me a thumbs up. Are we all okay with how we've gone about answering the questions here? Is everybody okay with that? Okay, there's like a bug flying around my ass. Ugh. Okay, needs to go, needs to go. Okay, that's fine, Remafile. That's okay, Oratilwe. We're going to do another question just now. Okay, sorry, teacher Nels. I didn't know that you were not a host. There we go. You've been made co-host. It's not that bad, Enke. I don't think it's that bad. I think this question was quite calm compared to what I'm about to show you guys in a little bit. This one is quite calm. I'm sorry, guys. Okay, all right. Okay, let's get to the next question. Now, the next question says, we are given a parallelogram PQRS. Now, before we even start, let us think about the properties of a parallelogram. Give them to me. What do we know about the properties of a parallelogram? Come on, peeps. Good. Now, we can't just say parallel lines. We must be we must be specific. Thank you, Isayan. Opposite sides are equal. Opposite sides are equal. Good. Not all the sides though, Jessica, just the opposite sides. So unlike the rhombus, where we can say that all the sides are equal, we can't say the same about a parallelogram. In a parallelogram, only the opposite sides are equal. So this side and that side is equal, and this side and this side is equal. Okay, good, Onako. Again, diagonals also bisect. The only difference is they don't bisect at 90 degrees. Okay, good. Diagonals bisect. Excellent. Opposite angles are also equal. Thank you, Boucher. Opposite angles equal. What else? What else do we know? Good. Nicole already gave me the one I was looking for. I didn't actually see that. Opposite sides are also parallel. All right. So it's important that we know all of this information before we jump in. All right. Jessica, unfortunately, in a parallelogram, no 90-degree angles anywhere in sight. Not a single 90-degree angle. Okay. Unless we're talking about a rhombus, because technically a rhombus is also a parallelogram, but that's another day. That's a story for another day. Okay. A rhombus is a parallelogram, but a parallelogram is not a rhombus. Woo! Okay, I'm going to start confusing people. All right, let's not go there. All right, so today's, excuse me, today's question says, prove that the diagonals bisect each other. We need to prove Our job is to prove that the diagonals bisect each other. So can we automatically say that the diagonals bisect because it's properties of a parallelogram? Can we say that? Can we just say diagonals bisect? No, we can't. We can't just say properties of a parallelogram. No, because that's the one thing we're trying to prove. We're trying to prove that they bisect, right? But we know that when they bisect, what do they do specifically? We said that when they bisect, they what? Correct. They cut this in half. Okay, they cut what we need to do in half here. So technically, what we're trying to prove is that QM is equal to MS. We must prove that this is cut exactly in half. Or we must also prove that PM is equal to MR. We must prove one of those things, because if this thing is equal to that one, and that one is equal to that one, that shows us that the diagonals bisect. Give me a thumbs up if what Ma'am is saying makes sense. Are you guys with me here? If we want to prove that the diagonals bisect, we must prove that where they've cut each other, they've done it exactly in half. Okay, beautiful. So let's actually follow protocol, because there's a way for us to have to do this. All right, we first have to say RTP. What does RTP stand for? Who remembers? RTP? Who knows? What does RTP mean? We should know at this point in time. Girls. Okay. Ooh, Lulu. Welele. Before my time, not RIP, not rest in peace. Not rest in peace. Okay, RTP means, okay, it means we are required to prove. And I want you guys to write this down, because it also comes out in your matric paper. It's very important that we know that RTP stands for required, not RIP. Not rest in peace, guys. Required to prove. Okay. Now, lady, I had just assumed that your teachers had made the pots to happen. I thought your teachers had made the pots to be done. That's why I didn't even bother to look at what is happening where with what. Okay, please write that down. Write it down. RTP means required to prove. All right. So what I'm going to do then is I'm going to say that I'm required to prove that PM is equal to MR. That is my whole job. I'm going to prove that this part over here is equal to this part over there. That's what we're going to do. All right. So how are we going to prove that these two things are equal to each other? What do we normally see? My parallelogram is made up of what? I'm going to ask again. It's also made up of, yeah, that's it, Boucher. That's more than enough. That's more than enough. Yes, correct. It's made up of triangles. And if we want to prove that the particular sides are exactly equal, what exactly do we need to prove? What kind of triangles would I want? My two triangles must be what? Yes, beautiful. My two triangles must be congruent. So what we're actually going to do is prove congruence. Okay, yes, oratilwe, in mathematics, we don't say that the triangles are equal, we say that they are congruent. All right. I feel like, you know what, teacher Nels, I may have done everybody a disservice. I should have done these a lot earlier. You know what I mean?
Yeah.
Or maybe you guys, what you need to do is tell your teachers, listen, ma'am or sir, can you just let us write the exam a little bit later? Because if I know anything about Teacher Coco is that she's going to go through the questions that you're going to ask me. So maybe let's write after she teaches me this part, because clearly, I'm sorry, guys. I'm sorry. I'll give you guys a cheat code after this. I'll show you guys. Okay, all right. Mfundo, you lucky fish. All right, so here's what we're going to do, guys. I'm going to pick my two triangles that I want to prove congruent. Okay, I'm going to say in triangle PQM, I'm going to use that triangle. And then I'm also going to use triangle. Let me see. I started at P and I went the long way down. So I'm going to start here. R, S, M. I'm going to use these two triangles. Those are the two triangles that I want to prove in. Okay, so I'm going to say in triangle. Oh, sorry, I forgot to write proof. Proof. In triangle PQM and triangle RSM. Let us talk, guys. Okay. Let's talk. What do we know about the angles and the sides of these two triangles? Let's talk, peeps. Remember, to prove congruence, I only need 3 reasons. 1, 2, 3, and yo. Yeah, just give me one. Okay, that's it. Thank you, Onako. Beautiful. Onako says M1 is equal to M3. And that is such a beautiful statement because of vertically opposite angles. Good. Vert op angles. That's reason number 1. Thank you. That is an angle. Good. That is an angle. What else do we know? Okay. Siamtanda says P2 is equal to R2. Agreed. Give me a good reason why. P2 is equal to R2. What is my reason? Let's talk about the reason. Mfundo, just saying parallel lines is not good enough. Thank you. Good. Alternate angles. Excellent. Alternate angles. And we also know the reason why we can say that is because PQ is parallel to RS. That's it. Boucher. Beautiful. I need one more reason. Give me one more reason, guys. And I need to tell you guys, because we've got 2 angles, we can't look for a third angle. Why is ma'am saying we can't look for a third angle? Correct, Mfundo. Because if I prove using angle, I didn't prove congruence, I proved similarity. So because I've already proven two angles, I now need a side. I definitely need a side. So which side am I going to look at here? Here is my hint. No. Onako, we can't say that because that's the thing we're trying to prove. Here's my hint. PQRS is still a parallelogram. What does that tell us? Correct. Yes, Naledi, beautiful. PQ is equal to RS. And the reason for that, what is my reason? It has something to do with the properties of a parallelogram. Teacher Nels, I can see you mouthing the answer. Don't tell them. Yes, Isayan, good. The opposite sides of a parallelogram are equal. Opposite sides of a palm are equal. Good. Now I've got all 3 of my reasons. Now I can say, therefore, triangle PQM is congruent to triangle RSM. All right. We can now say that they're congruent. And thank you, Mfundo, for our answer. Our reason for congruence is angle, side. That's it. Our reason for congruence is angle, angle, side. Well done. Now that we know that these two sides are congruent, what does that tell me about all the other sides of my triangle? If my two triangles are congruent, what does that tell me about the corresponding sides? That they are all what? They're all the same, correct. That's it, Jessica. They are all equal. Beautiful. They are all equal. Excellent. So now I can then say, therefore, that tells me that PM is equal to MR. Okay, and I did find out that we don't have to use CPCTC anymore. You can just say congruent triangles. You can literally use the idea that the triangles are congruent. You just write congruent triangles. That's my reason. All right. Give me a thumbs up, thumbs down. How are we? In fact, on a scale of 1 to 10, how confident are we that we can answer this question? Scale of 1 to 10. 1 being nope, and 10 being I got you. Okay. Yes, absolutely, Isayan. You know what? I feel like sometimes, Moa Lucy, I'm so sorry. I feel like sometimes you guys doubt yourselves because some of you guys really, really know what's happening. And in your mind, you're like, these maths teachers are trying to trick me. Where's the catch? There's no catch, guys. We're literally just trying to figure out, what do you know? And trust me, even if you don't know everything, you know something. And that's where your marks, even if you get 1 mark, just for writing that PQ is equal to RS, it's a mark. Okay. Abigail, there's no catch here. There's no catch. When we did Euclidean geometry, we started at congruence. It's always going to do something, it's always going to have something to do with either congruence or similarity, one of the two. Okay, so it's always going to be something along those lines. All right. Shall we continue? Let us continue. Okay, I'm very sorry for what I'm about to do next. Okay, here's our next challenge. Okay. All right. I knew this was going to happen. I knew this was going to happen. No, Mfundo, there's no leave button. I knew the weleles were coming. Let's go back. Okay. All right. Okay. I'm sorry to do this, but this does come out of a grade 10 paper. So I want you guys to remember, okay, repeat after me in the chat, repeat after me. I may not know everything, but I know something. I'm going to ask you guys again. I may not know everything, but I know what? What do we know? We don't know everything, but we know what? Tell me in the chat. We don't know everything, but I know something. Good. I don't know everything that needs to go into this question, but I know something. And trust me when I say that something is going to lead us to the answer we want. Okay, thank you so much. Okay, it's going to lead me somewhere. Let's start by reading the write-up. Let's start here. Let's start up here. Right. In the diagram, ABCD is a what? It's a parallelogram. Give me a thumbs up if we know the properties of a parallelogram. Correct, Isayan. Look at that. Isayan is already just like halfway through it. There we go. Good. We know something. We know the properties of a parallelogram. Good. So we know that ABCD is a parallelogram. Automatically, I know AD and BC are equal. 100% we know that. We know that AB and DC are also equal, right? I also know that AE and EC are equal. the diagonals bisect. I also know that DE and EB are equal. Look at what Anotida has already said, and we haven't even started yet. We haven't even started. Well done, Anotida. We're going to get there. We're going to get there. I just wanted to make sure that everybody's on the same page with me at the moment. All right, good. We know that something about that parallelogram. And then they tell you again that the diagonals of another parallelogram, DECF, intersect at G. They're also telling you that they are diagonals, some more. What does that tell us? That tells us that EG must equal GF. We know that for a fact. We also know that DG must equal GC because of that parallelogram over there. Right. But they keep going, guys. They keep going. They say the diagonals of parallelogram FGCH, another parallelogram there, FGCH, intersect at K, which tells me that GK is equal to KH. There's something else. And we know that FK is equal to KC. Right. So, guys, we are not in the dark here. We are not. And trust me when I say we're going to get there. Now, let's think about what it is that they want from us. Let's look at the question. The question says, prove that DB is equal to 4KC, is equal to 4KC. Let's go map these two out. Let's go look for DB. This is DB, right? And they say that DB is equal to 4KC. So we already know a couple of things. We want to make sure that we are connecting KC to DB. So Anotida, start us off again. You've already said something very important. So say it again. Put it in the chat again. I want everybody to see what you have said. Good. Naledi is just like bang, 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 bang. Now I see it, ma'am. Now I see it. Beautiful. Look at what Anotida has just said, everyone. Anotida has told us that DE is equal to 2KC. Let's see how Anotida has gotten there. All right. Let's see how he got there. He may have skipped a couple of steps. Okay. Okay. Hold on. I'm going to show you now, Jessica. Don't stress. Okay. This is supposed to be 4, by the way. Okay. Oh, DE. DE. Okay, so let's think about this. Okay, we know that KC is equal to KF, right? KC is equal to KF. That's where I'm going to start, actually. I'm going to start there. I'm going to say KC is equal to KF, right? But what do we know about the side FC? What is FC exactly? FC is the long side of parallelogram DECF, right? So I can then say let me not start by saying 2KC. Let me say KC plus KF is equal to what? Tell me, guys, what is KC plus KF equal to? Not the angle, Jessica. I'm looking for the side, my sweetie. What side is it equal to? KC plus KF is equal to, what is the side over here called? Good. It's called FC. Good. But FC also has another name. Which other side is also equal to FC? No worries, Ramrata. DE. Good. Not GH, my sweetie. DE. Right. Look at it. From here to there is also equal to there to there. All right. It's the same thing. Right. But I know that KC is equal to KF. Right. So what I'm going to do is I'm going to replace KF with KC. I'm going to remove KF and I'm going to replace it with KC. And then I'm going to remove FC and I'm going to replace it with DE. E. Give me a thumbs up if everybody understands what I've done here. Are you guys with me? Does everybody understand what ma'am has just done? Okay, Jessica, my sweetie, hand up. Hand up. I don't want to lose you here. Put your hand up for me, please, my sweetie. Let's talk. All right. Hello, my sweetie. How are you?
Fine, you.
I'm good, thank you. All right, let's talk. Okay, so do you agree that the thing that they want us to prove involves KC? They say that prove that DB is equal to 4KC. Yes?
Yes, ma'am.
Yeah. So we're gonna go start at KC, right? So they haven't given us any angles, my sweetie. Have they given us any angles in our drawing?
No, ma'am.
No. So we're going to use the sides. Okay. Now, I know, because this is a parallelogram, I know that KC is equal to, which other side is also the same size as KC?
KF, ma'am.
Good. We know that KC is equal to KF, right? That we know for a fact, right? There, do you see how ma'am has written that over here? Are you with me? Good. But I know that if they are equal, if KF and KC are equal, I can also say that KF is KC. I can also name KF KC. Do you understand what I did there?
Yes, ma'am.
Okay, good. So I know that KC plus KF, the whole distance, what's the distance from KC to KF? What's another name for that distance there? What can I call the distance from there? FC. So I've called it FC. Do you see that? Yes?
Yes, ma'am.
And we said that KF is also KC. So I'm going to take KF, and instead of writing KF, my sweetie, I'm going to write KC. Are you okay with me doing that?
Yes, ma'am.
Good. So I'm going to replace KF with KC, right? So what is KC plus KC? If I add the two KCs together, it's going to give me?
It's going to give you FC. It's going to be, yes. It's going to give you DE, ma'am.
Okay, good. Don't think about this part yet. Think about if I say to you that KC is equal to X and KC is also equal to X. What is X plus X?
It's going to give you 2KC.
Good. It's going to give us 2KC. Good. So I can say 2KC is equal to FC. But then because it's a parallelogram, my sweetie, I know that FC, the distance for FC is equal to what other distance?
DE, ma'am.
Good, DE. FC and DE are the same distance. So I can take FC and I can replace FC with what?
DE, ma'am.
Good. I'm going to take away FC and I'm going to replace it with DE. Okay. Are you following me? Are you with me?
Yes, ma'am. Yes, ma'am.
Beautiful. Good. Now let's think about this. What other side is equal to DE? Find me another side that's also equal to DE.
EC, ma'am.
Oh, not EC. Look, EC is a short side, right? It's not going to be EC. Which other side is equal to DE?
AB, maybe. No. Too long.
Okay, check what Mfundo's saying in the chat.
Oh, EB, ma'am.
EB, right. Because DE is a diagonal, yes? It's a diagonal. And the diagonal is bisected. It's bisected by AC. That means DE must equal which other side?
EB, ma'am.
EB. These two must be equal to each other. Yes?
Yes, ma'am.
So I can then say that DE is equal to EB. Right. But what happens if I add them together, Jessica? If I say DE
you're gonna get
plus EB, I'm going to get what?
You're going to get DB, ma'am.
Good. I'm going to get DB. I'm going to get that whole thing. Right. Get this whole thing there. DB. Good. dB. But I also know, what can I replace EB with?
With a DE, ma'am.
Good, with a DE. So I'm going to go ahead and I'm going to replace DEB with DE. Good. Do you remember what DE was called? Do you remember what we said DE was?
Yes, ma'am.
We said it was?
2.
KC, yes?
Yes, ma'am.
So I'm going to take both of my DEs and I'm going to replace them with 2KC. Replace this DE for me with 2KC. Tell me what I'm going to write.
So it's going to be 2KC is
plus
plus DE.
What is DE?
No.
What's another name for DE?
DE is dB, ma'am.
Look up here.
2
We said that
KC,
we're replacing DE with 2KC, but this is also DE. So I'm also going to replace DE with?
DE with 2KC, ma'am.
With 2KC, good. So now I have 2KC plus another 2KC. And all of that is equal to dB. Can you clean up the side for me, my sweetie?
So it's then going to be 4 KC is dB, ma'am.
Correct. Look at you, my sweetie, with a full 4 marks. Well done. 1, 2, 3, 4. Amazing.
You,
well done, my sweetie. Okay. And I love you for telling me that you don't understand and that I must slow down. I'm more than happy to. Well done, my sweetie. I want you to keep trying. Okay. See, I told you, my sweetie, we don't know everything, but we know something. See what I mean?
Yes, ma'am.
Told you. Well done, Jessica. Amazing stuff. All right. Okay. Let me ask you in the chat. Was that as bad as we thought it was going to be? Yes or no? Was it as bad as it was going to be, as we thought in our brains when we saw it? So, ma'am, we literally just have to list all the sides that are equal that lead to the thing we want to. 100%. 100%. I know you guys see things and then jiggy, you're just like, yo, yeah, the world, it's coming to an end. Hey. But look at what you guys were able to do. Look at what you were able to do. Yes, guys, remember, I don't know everything, but I know something. And you're always going to get somewhere if you know something. Well done. I feel like you all deserve just a high five. You know what I mean? No, Unati, we never, ever, ever leave questions open. We never, ever do that. Okay. We always know something. We never, ever leave a question behind. All right. Okay. Are we ready for some more? Yes? It is, DeAndre. It's just because of the diagram, guys. I know. The diagram looks like, yeah, ma'am, come and rescue us. It's never that deep, guys. Thank you, Teacher Nels. I love that. I love that. Yes, it's David and Goliath. It's a David and Goliath story. Guys, it only takes a little bit for you to get where you need to go, guys. Don't give up. Don't give up. All right, let's get to the next one. Let's get to the next one. Question 7. All right, this one is also a bit of a doozy, but okay, it's all about knowing what part of Euclidean geometry is this. Who remembers? What are we looking at here? Another monster. Oh, guys, come on. It is, no, this is Euclidean geometry. But yes, it has something to do with triangles. That's it. Onako, good. It's the midpoint theorem. Good. This is the midpoint theorem. We need to remember the midpoint theorem. Okay. And it's lovely because they start us off by reminding us what the midpoint theorem says. Okay. It says here, complete the statement so that it is true. It says, the line drawn from the midpoint of one side of a triangle parallel to the second side, what does that line do? Yes, Isayan, what does it do? Yes, Naledi, beautiful, 100%. Most people don't remember. Most people remember how to use the midpoint theorem. They don't remember what it says. Correct. The line drawn from the midpoint of one side of a triangle parallel to the second side bisects our third side. Bisects the third side. Good. And we now know so much about that word bisects. This word, it's very, very helpful. It's very nice. Wherever we see bisect, we know, yeah, ma'am, our life has just become nice and easy. Because we already know that somewhere something's going to be equal to something else. Yes? Okay, good. Let's start over here. Let's read the information we've been given. All right, it says here, ACS is a triangle. P is a point on AS. And R is a point on AC such that PSRQ is a parallelogram, another parallelogram. Let's go map out our parallelogram. It says here PS, RQ. Okay. So before we even continue, what do we know? PS is equal to which other side? Naledi, I didn't even finish my sentence. I didn't finish my sentence. Thank you, Naledi. PS is equal to QR. See, guys, we don't know everything, but we know something. Good. Thank you. What else do we know? What else does this tell us? What else does this tell us? Somebody has already alluded to it. Good, Naledi. Excellent. The lines are parallel. Which two lines are parallel? Tell me. Tell me, guys, which two lines are going to be parallel? Good. PQ and, QP and RS are parallel. Good. So we know that. Okay, let me clean this up because I'm now making it ugly. QP and RS parallel. Good. What else? Where else do we have parallel lines? We're not done. Fundo, don't ask Naledi. Thank you. Naledi says QR and PS are also parallel. Good. We know that. That is very important as well. Good. QP and RS. Good. And also QR and PS. Well done, guys. We're off to an amazing start. Okay. We're off to a great start. Good. Then it says PQ intersects AC at B such that B is the midpoint of AR. What does that tell us about the length of BR and AB? Yes, Boucher, 100%. BR is equal to AB. Good. They are equal. Excellent. Then it says QC is joined. So they've joined QC. Good. Also, CR is equal to PS. Okay, good. Now, look at what they've done, guys. They've said that PS is equal to CR. If you look over here, guys, that side and that side are equal to each other. What does this make this part of this part? Yeah. What does that make that over there? What do I have there? A what? It is a triangle, but a very specific type of triangle. It's not a 90-degree triangle. It's not scalene. Yes, Mfundo. 100% Kamogelo. That's it. It's an isos. It's an isosceles triangle. Well done, guys. That's it. We know now that angle Q1 is equal to what other angle? Q1 is equal to what? to C1. Beautiful. Q1 and C1 are therefore equal. All right. Look at that, guys. Look at all that information that they've given us. And then they've told us that the length of BP is 60 millimeters. All right. That's a lot of information. Lots of information. They've also told us that C1 is 50 degrees. Thank you, Mfundo. I didn't read that part. So C1 is also equal to 50 degrees. Look at that. That means Q1 is also equal to 50 degrees. 50 degrees. Yeah, we're off to a great start, guys. Amazing stuff. Amazing stuff. Right. Let's get to the questions now. Now they're saying, calculate the size of angle A. It's a lot of work. Okay. This is the only question we're going to do. Otherwise, we're going to run out of time because there's only 6 minutes left. We're not going to do 7.2.2. I'm going to leave that to you guys to go and try. All right. Let's talk about how to find the angle, the size of angle A. So let's take what we've been given and see how we can connect it. See how we can connect it to the angle A. All right, who wants to start us off? Who's got an idea? Good, Rimufile. CR is equal to PS. That is a given. Thank you very much. Good. CR is equal to PS, given. Mfundo we, leave Naledi alone. CR is equal to PS, and that is given. Good. Where do we go from there? Where do we go from there? Thank you, Rimufile. Where do we go? I'm not sure about that, Jessica. I don't think P1 and P2 are going to be equal. Not quite. What other side is equal to PS, guys? Think about it. What other side is equal to PS? Good. PS is equal to QR. Good. That's not given to us. PS is equal to QR. Why can we say that PS and QR are equal? Good. It has something to do with opposite sides. Correct. Opposite sides of a parallelogram are equal. Good. Opposite sides of a palm are equal. Good. Good. Excellent. Good. Yes, Remufilwe, you're onto something there. Good. Now we know that Q1 is therefore equal to C1. What's our reason here? We know that it has something to do with a sure, excuse me. It has something to do with an isosceles triangle, but we can't just say isos. We can't say isosceles triangle. We need to use the actual reason. Who remembers what the actual reason is? It's angles opposite equal sides. Okay, we cannot just say isos triangle. Okay, we have to say angles opposite equal sides. Okay. Sure, DeAndre, can I ask you to DM Teacher Nelly with that query, please, my sweetie? Okay, she's got a query and she'll message you now. Just copy paste DeAndre to Teacher Nels. Okay. Isos triangles. How? Okay, good. What does that then tell us about angle R3? What do we know about this angle over here? What is the size of angle R3, guys? Therefore, angle R3 is equal to? Correct. Remufilwe is correct. I want somebody to tell me why Remufilwe is correct when she says that angle R3 is equal to 100 degrees. Yes, that's it. Onako, beautiful. The exterior angles of a triangle. Good. The exterior angle, not even angles, the exterior angle of a triangle is equal to the sum of the two interior angles. Good. Exterior angle of a triangle. We are almost there, guys. We are almost there. We are almost there. One more step. One more step. Let me explain that one more step to you guys. Thank you, Teacher Nels. Here is your last step. What do we know? What does angle A need to equal to? Okay, I don't know how we've gotten to that conclusion on Nako, that B1 is equal to 130. Yes, correct. Who said that? Who said that? Who said that? Yes. A is therefore equal to 100 degrees because of alternate angles. Alternate angles. There we go. Beautiful. It's either the F or the Z. It's the Z we're actually looking for. Okay, it's the Z in this direction. Okay. Therefore, A is equal to 100 degrees, alternate angles, and my two, my two parallel lines are going to be QR and AS. Those two need to be parallel. Okay, QR is parallel to AS, and I have to run away. Okay.